Hello and welcome to yet another South Korean college scholastic ability test video. I have already uploaded 2 videos about 2 other problems from this year's test, and you can check the links in the description. But I still want to share one more problem with you, so let us dive into the problem. For a function fx given as 1/9 of x times x minus 6 times x minus 9, and a real number t which is in between 0 and 6, function gx is given as, when x is less than t, gx equals fx, and when x is greater than or equal to t, gx equals minus x minus t plus ft. What is the maximum value of the area enclosed by the graph of the function y equals gx and the x-axis? So the problem itself is pretty straightforward, and obviously the most important part is to understand the graph of this gx, which is divided into 2 cases. First, let's start with the graph of fx. It is quite easy since this is a cubic function that is really easy to draw. It's just a typical cubic function graph that passes 0, 0, 6, 0, and 9, 0. But for the graph of gx, we have to divide cases as given in the problem, and that is where the new variable t appears. At least when x is less than t, the function gx is just given as fx. And t is in between 0 and 6, so t is located somewhere in here. Therefore, we obtain this graph, where the graph of gx is identical to the graph of fx, and this t is in between 0 and 6. But what about the part where x is greater than or equal to t? Well, when the value of t is fixed, then from the perspective of x, t and ft can be considered as constants. So this is just a linear function of x, which is a straight line, and the slope of the line is minus 1. In addition to the slope, in order to determine a line, we require at least one point that the line passes through, and one such point is when x equals t, which gives y equals ft. So this is the line with slope minus 1 and passes t, ft. And if we go back to here for a moment, this point right here is when x equals t, so this point is t, ft. So the straight line passes this point, so we obtain this graph. This point right here is t, ft, and the slope of this line is minus 1. So now that we have obtained the graph of gx, let's move on to the next part of the problem. The goal of this problem is to find the maximum value of the area enclosed by the graph of the function y equals gx and the x-axis. That is, the maximum area of this shaded region. And from this demonstration where the value of t is changed between 0 and 6, it is clear that the area of the shaded region becomes maximum when t is somewhere in the middle. So now let us do some mathematical formulation and actually find that optimum value of t. As you can see, the entire area of the shaded region, which we will call A, consists of 2 regions divided by x equals t, which we will call A1 and A2. On the left side, the function is fx. Therefore, area A1 can be obtained by integrating fx, where x changes from 0 to t. On the right side, the function is this straight line. But instead of substituting this ft with the polynomial expression and integrating it, let us use the fact that the shape of this region is a right triangle. More precisely, the right isosceles triangle, because the slope of this line is minus 1. So these 2 lengths are equal. And since this point is t, ft, this length is t, and this length is ft. Therefore, this length is also ft. Therefore, area A2 can be expressed as 1/2 ft squared, the area of the triangle. So we have obtained this, and we want to maximize this value. But instead of substituting the given expression for fx right away, let us approach this a bit more smartly. You see, the occurrence of maximum value means that the derivative must be 0 in that case. Therefore, we first try to obtain the derivative. And since now t is the changing variable, we must take derivative with respect to t. So the derivative is, if we differentiate the first term with respect to t, it simply gives ft. This is just the first part of the proof of the fundamental theorem of calculus. And for the second term, we have to use the chain rule. First, we obtain ft by the power rule, and then we must multiply its derivative, f prime t. Therefore, we have ft times 1 plus f prime t. Here, this t can have values only between 0 and 6, and we know that ft remains positive there. Therefore, in order for this derivative to become 0, 1 plus f prime t must be 0. So we have obtained this condition, and now we finally use this expression for fx. So first we expand, then we obtain the derivative of fx, which is 1/3 x squared minus 10 over 3x plus 6. Therefore, this condition can be written as 1 plus 1/3 t squared minus 10 over 3t plus 6 equals 0, which rearranges to t squared minus 10t plus 21 equals 0, which is factored into t minus 3 times t minus 7 equals 0. And since t is greater than 0 and less than 6, t equals 3. Therefore, area A is maximum when t equals 3. And finally, let us calculate that maximum area. Using the previously obtained expression, by letting t equals 3, the maximum area is given as integral from 0 to 3 fx dx plus 1/2 f3 squared. And from the given expression of fx, you can easily find that f3 equals 6. So we have integral, the expression for fx, plus 1/2 times 6 squared, and by integrating, we have 1 over 36 x to the power of 4 minus 5 over 9 x cubed plus 3x squared, and the second term gives 18, and the integral part gives 57 over 4, so this plus 18, which gives 129 over 4. Therefore, from the given multiple choices, the correct choice is choice 3. So that was another beautiful calculus problem from this year's famous South Korean test. Thank you very much for watching, and if you enjoyed this video, please go check my other videos as well, and don't forget to hit the like and subscribe buttons, and I will see you in another video.